All right, welcome back everybody. In this video we are going to continue and finish up our lesson on section 10.9 from AP Calculus BC, determining absolute and conditional convergence. And we're going to continue right where we left off. We're going to pick up here with example 5. This should be a pretty short video. We've just got 2 examples to do, and then we'll be done. All right, example 5. Find the values of x that make the series converge absolutely. So we're looking for values of x that will make the absolute value of this series convergent. So what we're going to do is we're going to first find the absolute value of this series. And the absolute value of this series is going to take place when we get rid of this alternating term, and so this becomes our series. And now we want to find the values of x that make this series converge. In order to do that, the easiest way to do that is going to be to use the ratio test. So I'm going to go ahead and do that. We'll use the ratio test, limit as n goes to infinity of quantity n plus 1 times quantity x plus 2 to the n plus 1 all over 5 to the n plus 1 times the reciprocal of the nth term and this turns into the limit as n goes to infinity of the absolute value of n plus 1 over n times, we've got an x plus 2 in the numerator and a 5 in the denominator. And the limit of this, as n approaches infinity, is going to be the absolute value of x plus 2 over 5. Now, in order for this series to converge, we're using the ratio test, the result of this limit must be less than 1. And so that's going to be our relationship that we set up to determine when the series converges absolutely. And so we'll set up our equation or inequality here. This has to be between -1 and 1. We multiply all 3 parts by 5 and subtract 2 from all 3 parts. And boom, this is the interval on which this series converges absolutely. All right. Example 6. Find the values of x that make the series converge absolutely. We're going to do that again. Well, notice here we don't have an alternator, so ba-boom, we can just go ahead and apply the ratio test to this series. We're going to take the limit as n goes to infinity of the absolute value of x minus 3 to the n plus 1 all over n plus 1 quantity squared times the reciprocal of the nth term. And so this turns into the limit as n goes to infinity of n squared over n squared plus 2n plus 1 times, looks like the quantity x minus 3. And so the limit of all that, as n goes to infinity, is just going to be the absolute value of x minus 3, which we need to have be less than 1. And so we set up our inequality here. And we're going to add 3 to all the parts. That makes that 2, that x, and that 4. And that is the interval on which this series is going to converge absolutely. Outside of that interval, will not converge absolutely. Now, let's take a step back here for a second before we close up shop on this. And something we should do, and I'm going to have to do it in example 6. I didn't need to do it in example 5, but I'm going to do it anyway. Let's talk about what happens at these endpoints. Because the ratio test gave us this interval, and it is possible that the series could converge absolutely at these endpoints. So let's see what happens at these endpoints. If I substitute -7 in here for x, that makes this right here -5 to the n. And when I multiply that times the -1 to the n, that becomes 5 to the n. And so all those things cancel out. And at this point right here, this becomes the series, the sum from 1 to infinity of n. Now, if this converges absolutely, then we would need to include this endpoint, but it doesn't. So we do not need to include this endpoint in our interval of places, values of x that make the series converge absolutely. Same thing here, if we put 3 in here, it gives us 5 to the n, then at that point the series is the sum from 1 to infinity of negative 1 to the n times n, which again, that diverges by the nth term test. So we don't need to include either of the endpoints in example 5. And I moved so quickly past that because I knew that we didn't need to include them. But in example 6, we've got to pay attention to the endpoints. If I put 2 in here, that gives me the sum from 1 to infinity of negative 1 to the n over n squared. The absolute value of this is 1 over n squared. Does that series converge? Yes. Therefore, this series converges absolutely. Therefore, 2 is included in this interval of places where this series converges absolutely. If I put 4 in there, it just jumps right to sum from 1 to infinity of 1 over n squared. We know that converges, therefore it converges absolutely, so we're going to need to include that endpoint as well. All right, that takes us to the end of our lesson and the end of the first half of Unit 10. Second half of Unit 10 will be coming up soon, where we're going to do all kinds of fun stuff with infinite series. All right, see you then. Enjoy the rest of your day, and for now, goodbye.